All right, everyone, welcome to our deep dive into SphereX, which is NASA's brand new space telescope.
Oh, this is going to be exciting.
Yeah, it really is.
It is.
It's set to launch on February 27th from Vandenberg Space Force Base, so not very far away now.
Very soon.
And I think what's really cool about SphereX is that it's shaped like a giant megaphone, and it's going to create the most comprehensive, colorful map of the entire sky, but not in the way that we think.
How with our eyes?
Yeah, not invisible light, exactly.
Yeah.
So we're talking infrared light, the kind that we can't see with our naked eyes.
That's right.
And for this deep dive, we've got, intel straight from the source, NASA's Jet Propulsion Laboratory. So
The best people to talk to.
absolutely.
Okay.
By the end of this, you'll know what makes SphereX so unique and how its discoveries could literally change everything we know about the universe, including the potential for life beyond Earth.
Big questions.
Huge questions.
Yeah.
So, to kind of kick things off, can you tell us a little bit about what SphereX will actually be doing out there in space?
Well, I think the best way to think about SphereX is as this, it's like a giant prism in space.
Okay.
You know how a prism will split sunlight into a rainbow?
Right. Yeah.
SphereX will do that, but on a cosmic scale. So
Mhm.
it splits infrared light from stars and galaxies into 102 different colors.
102.
Colors, yeah.
Wow.
Or wavelengths.
That's like having 102 telescopes in one.
Yeah, it is.
I'm already intrigued, but what can we actually learn from all of those colors?
This is where the magic of spectroscopy comes in.
Okay.
So each color tells us something different about the object emitting the light.
Oh, interesting.
It's kind of like reading fingerprints, but for stars and galaxies.
Right. Okay.
We can figure out what they're made of, how far away they are, and even how fast they're moving.
So SphereX is basically going to give us this incredibly detailed map of the universe, but in 102 colors instead of just, the few that we can see.
That's right.
I mean, it's incredible.
A very colorful map.
Very colorful. Yeah, more colorful than anything we've ever seen before.
Yeah.
So, what are some of the big mysteries that you think SphereX will help us solve?
Well, SphereX is really designed to tackle three big questions.
Okay.
First, it's going to help us understand something called cosmic inflation.
Okay.
Now, imagine the universe right after the Big Bang.
I'm trying to.
In just a fraction of a second, it expanded trillions upon trillions of times its original size.
Yeah, that makes my head spin just trying to imagine that.
Yeah.
How can SphereX help us understand something that happened so long ago?
Well, it's going to map over 450 million galaxies, and it's going to look for these very subtle patterns in their distribution.
Okay.
These patterns are kind of like echoes of that initial expansion.
Oh, wow.
And by studying them, we can learn about the physics behind inflation, which could rewrite our understanding of the universe's origins.
So it's like looking for clues in the aftermath of this cosmic explosion.
That is, yeah.
So that's one big question.
Yeah.
What's next on SphereX's to-do list?
The next thing it will do is measure something called the total galactic glow, which is essentially all the light from every galaxy in the universe.
All the light combined.
Combined, yeah.
Wow.
This will give us a much clearer picture of how much light there is in the universe, including light from sources that we haven't even discovered yet.
It's like taking inventory of all the light in the universe.
Yeah, it is.
That's pretty incredible.
Yeah.
Why is that important?
Well, so think of it this way. We know the universe is expanding,
Right.
but we're not exactly sure how fast.
Okay.
By measuring the total amount of light, SphereX can help us figure out the energy balance of the universe and how that expansion is changing over time.
So it's like understanding the engine that's driving the expansion of the universe.
Yeah, exactly.
Okay, so we've got cosmic inflation.
Yeah.
We've got this total galactic glow.
Uh-huh.
What's the third big question SphereX is going to tackle?
This one might be the most exciting. SphereX is going to search for the building blocks of life.
Okay, now we're talking.
Yeah, things like water ice and other frozen molecules in our galaxy.
This is where things get really interesting.
Yeah.
How exactly is SphereX going to hunt for those life-sustaining molecules?
Well, it's going to focus on two key areas. Stellar nurseries, where stars are born, and the disks of gas and dust that swirl around young stars, where planets form.
Okay.
These are the places where we're most likely to find the ingredients that are necessary for life as we know it.
So it's like SphereX is a cosmic detective searching for those molecular clues in the vastness of space.
It's a good way of putting it, yeah.
But it's not like Hubble or Webb, which zoom in on individual objects.
No, this is a wide-angle view.
Right, SphereX is all about that wide-angle view.
Yeah.
So how does that work with the other telescopes out there?
So I guess the way to think about SphereX is as a scout. So it's going to scan the entire sky and identify any interesting targets. And then telescopes like Hubble and Webb can take a closer look, providing those really high-resolution details that can help us confirm what SphereX has found.
So it's a real team effort.
It is.
Each telescope has its own strengths, and
Yeah.
they all work together to give us a more complete picture.
Yeah, it's like having a whole set of tools in a toolbox. You wouldn't use a hammer to tighten a screw.
Right.
Each instrument has its own job.
Exactly, exactly. They each bring something unique to the table.
Yeah.
So we've talked about, what SphereX is looking for, but how does it actually see these faint objects so far away, especially in infrared light?
Well, to detect those really faint signals, SphereX has to operate at a very, very cold temperature, -350 degrees Fahrenheit.
Wow, that is cold.
That's because any heat from the telescope itself
Mm.
would interfere with its ability to see.
It would create its own infrared glow, wouldn't it?
Yeah, exactly.
Okay.
So to keep it that cold, it uses a passive cooling system. Imagine a thermos. You know how it keeps your drink either hot or cold?
Right, keeps the temperature stable.
Yeah, SphereX's cone shape actually works in a similar way,
Okay.
shielding it from the sun's heat and allowing it to stay at that super, super low temperature.
So it's basically a giant thermos in space,
Yeah,
perfectly designed to capture those faint infrared signals.
that's right.
We've talked a lot about water ice and its importance in the search for life, but I understand there's a bit of a mystery surrounding water in space.
There is.
Like, where is it all?
Yeah, previous missions have found far less water vapor in space than scientists expected.
Oh, really?
Yeah.
So where's it all hiding?
Well, that's one of the things that SphereX will help us figure out.
Okay.
So its 3D data will let us peer into those dense molecular clouds, the ones where stars and planets are born, and see how much water ice is actually locked away inside them.
Ah, so it's not that the water's not there, it's
Yep.
just in a different form.
It's hiding, yeah, as ice.
Fighting as
Yeah.
ice. So SphereX is on the case like a cosmic detective trying to solve this mystery of the missing water.
That's right.
But what does all of this have to do with, the search for life beyond Earth?
Well, imagine if SphereX discovers that water ice is incredibly abundant in these planet-forming regions.
Okay.
That would suggest that one of the key ingredients for life is widespread throughout the galaxy.
Right. And if those building blocks are there,
Yeah,
the chances of life emerging on other planets, well, they increase dramatically.
they do.
I mean, this is just the tip of the iceberg, right?
Yeah.
I feel like we've only just begun to explore the potential of SphereX.
We have.
But for now, I think we'll leave it there.
Yeah.
We've got a lot more to unpack, and we'll be back with more fascinating insights into this groundbreaking mission in our next segment, so stay tuned.
We'll be right back.
Okay, so we're back and ready to keep going with our deep dive into SphereX.
Oh, let's talk about.
We've talked about this amazing 102 color map
Yeah.
of the universe it's going to create. But what are we really hoping to learn from this? I mean, are there specific things scientists are looking for, or is it more about the unexpected discoveries?
Yeah, it's a bit of both,
Okay.
actually. I
Go
mean,
ahead.
there are some specific questions SphereX is designed to answer,
Okay.
but the most exciting discoveries are often the ones that we don't anticipate.
Right, like you don't even know you don't know yet.
Yeah, it's like exploring a new continent. You set out with a plan, but you're open to the unexpected.
I love that analogy.
Yeah.
So we've got our roadmap, but we're also prepared for some detours into the unknown.
Yeah.
Now, you mentioned earlier that SphereX might help us solve the mystery of the missing water in space. Can you talk about that a little more?
Sure.
Where do scientists think all that water went?
Well, I mean, it hasn't actually gone anywhere.
Okay.
It's just not where we expected it to be,
All right.
at least not in the form of vapor.
Right. Okay.
Those dense molecular clouds we talked about.
Yeah.
They're incredibly cold.
Yeah.
And scientists think that a lot of the water that we're looking for is frozen, actually frozen as ice within those clouds.
So it's hiding in plain sight, locked away as ice in these
Yeah.
vast cosmic refrigerators, I guess you could call them.
That's a good way to put it, yeah.
But how does knowing this help us in our search for life beyond Earth?
Well, if SphereX can find evidence of abundant water ice in these regions where stars and planets are forming, it would suggest that one of the key ingredients for life is widespread throughout the galaxy.
So the more we understand about where water exists in the universe, the better we can target our search for, these potentially habitable worlds.
Right, exactly. Connecting the dots.
Yeah, exactly. It's all about connecting those dots.
Yeah.
Now, shifting gears a bit, let's talk about SphereX's role in understanding those earliest moments after the Big Bang.
Sure.
We briefly touched on cosmic inflation, but can you delve a little deeper into what it is and how SphereX will help us study it?
Yeah. So cosmic inflation is one of the most mind-boggling concepts in cosmology.
I can imagine.
It really is. So imagine the universe in its infancy, like this tiny speck, smaller than an atom.
Okay.
Then, in just a tiny fraction of a second, it explodes outward, expanding trillions upon trillions of times in size.
Okay, I'm already lost.
Yeah.
How can we even begin to understand something that happened that quickly and so long ago?
Well, the key is to look for the fingerprints of inflation in the universe that we see today.
Okay.
Remember those ripples we talked about?
Yeah.
Cosmic inflation would have created similar ripples in the fabric of space-time, and those ripples would have influenced how matter and energy were distributed throughout the universe.
So these ripples are like echoes of that initial expansion, and
Yeah.
they're imprinted on the structure of the universe itself.
Exactly.
Right.
By mapping the positions of hundreds of millions of galaxies, SphereX will essentially be measuring those patterns, those echoes of the Big Bang.
So it's like a cosmic archaeologist
Yeah.
digging into the deepest layers of time to uncover the secrets of the universe's birth.
That's a great way to put it.
I mean, that's incredible, but how can it see back that far?
Yeah.
We're talking about galaxies whose light has been traveling for billions of years.
That's where the idea of redshift comes in.
Okay.
As light travels through the expanding universe, its wavelengths get stretched out, shifting towards the red end of the spectrum.
Okay.
The farther away an object is, the more redshifted its light is.
So by analyzing the redshift of light from these distant galaxies, SphereX can determine how far away they are,
Yeah.
and, more importantly, how long ago that light was emitted.
That's right, like a cosmic time machine.
Yeah, it is. So by studying these distant galaxies,
Yeah,
SphereX can help us understand what the universe looked like in its early stages,
exactly.
how galaxies formed and evolved over time,
Mhm.
and how the structure of the universe itself has changed.
Yeah.
I mean, this is officially blowing my mind.
It is pretty amazing.
We're using a space telescope to unravel the history of the universe.
We are.
But let's shift gears just for a moment and talk about the data itself.
Okay.
What happens to all the information that SphereX collects?
Well, one of the most exciting aspects of this mission is that all of the data that SphereX gathers will be publicly available.
Really?
Yeah.
So anyone, like professional astronomers,
Anyone.
citizen scientists,
Scientists, yeah.
they can access this data.
Yeah, access it, analyze it, yeah.
So it's not just about like a few scientists in a lab making these groundbreaking discoveries.
No.
It's about democratizing access to this incredible information.
Yeah.
Allowing anyone with a passion for space to contribute to our understanding of the universe. I mean, I love that. It
Yeah.
really brings home that idea that we're all part of this cosmic journey of discovery.
Yeah.
So speaking of mysteries,
Yeah.
let's get back to SphereX's search for those elusive building blocks of life.
Okay.
We've talked about water ice, but what other molecules is it looking for?
So it'll be looking for a variety of different molecules, things like carbon dioxide, methane, and ammonia.
Okay.
And these molecules, along with water, are considered essential for life as we know it.
So it's like SphereX is searching for that cosmic recipe book, you know, that list of ingredients that could lead to the emergence of life.
Yeah, that's a great way to put it.
By mapping the distribution of these molecules throughout the galaxy, SphereX will help us understand where the potential for life might be highest.
Exactly, like identifying the most fertile ground
Okay.
for life to take root.
But I have to ask, how can SphereX tell the difference between these molecules in a distant star-forming region
Yeah.
and, let's say, the same molecules here on Earth?
Well, that's where the power of spectroscopy comes in again.
Okay.
Remember that SphereX splits the light into 102 colors.
Right.
Each molecule absorbs and emits light at very specific wavelengths.
Okay.
So it creates a unique spectral fingerprint.
So it's like each molecule has its own barcode, and SphereX can read those barcodes to identify them, even from millions or billions of light years away.
That's right.
And not only can it identify them, but it can also determine their abundance and how they're distributed.
Yeah, how much there is
Right.
and where it is.
So we're talking about a 3D map of the potential for life in the Milky Way.
Yeah, exactly.
But let's be realistic here. SphereX isn't going to send back pictures of alien civilizations, right?
No, it's not going to do that.
Okay.
SphereX isn't designed to directly detect life,
Okay.
but it's designed to identify the environments where life might be possible.
So like narrowing down the search.
Yeah, think of it like, You're looking for a place to live.
Okay.
You wouldn't just randomly pick a spot on a map.
Right.
You look for areas with the features that you want, good schools, nice parks, you know.
Right, right. You want the best neighborhood.
Yeah, exactly. So SphereX is doing something similar on a cosmic scale. It's helping us pinpoint the regions that have the right ingredients for life.
So it's like a cosmic real estate agent
Yeah, I like that.
showing us the most promising neighborhoods in the galaxy.
Exactly.
I mean, this is an incredible mission, and I feel like we've only just scratched the surface of what
Yeah.
SphereX might reveal.
Uh-huh.
But we are running out of time for this segment, unfortunately.
Die.
But we'll pick up where we left off in the next segment, and we'll dive even deeper into this fascinating world of SphereX and the search for life beyond Earth.
Sounds good.
So stay tuned, everyone, because the best is yet to come. All right, welcome back to our deep dive on SphereX, the incredible new space telescope from NASA.
It's going to be amazing to see what it discovers.
I know, right? In the first two parts, we covered so much, like cosmic inflation and the total galactic glow.
Right. And how it's going to map the entire sky.
Exactly. But now it's time to tackle that big question.
The big one, yeah.
Are we alone in the universe?
Well, that's what we all want to know.
I think so.
And SphereX could get us closer to an answer than ever before.
Okay, so remind us, how exactly will SphereX search for signs of life beyond Earth?
It won't be looking for, aliens waving at us or anything.
Right, no little green men.
No. Instead, it's going to map the distribution of those essential molecules. Life's building blocks.
Right, the ingredients for life as we know it.
Exactly.
We've touched on this, but can you go a little deeper? What molecules are we talking about?
Okay, so we're talking about water ice, carbon dioxide, methane, ammonia,
Okay, so the basics.
the basics, but these are the foundation for complex organic molecules.
The building blocks of life itself.
Exactly.
So it's like SphereX is making a cosmic recipe book showing us where the ingredients are.
That's a great way to think about it. And by mapping where they are, SphereX will show us the areas with the highest potential for life.
This is where it gets really interesting for me. How can SphereX tell the difference between those molecules, in a distant star system versus here on Earth?
Well, remember how SphereX doesn't just take pictures, it analyzes light.
Right, splitting it into 102 colors.
Exactly. And each molecule has a unique fingerprint, absorbing and emitting light at specific wavelengths.
So each molecule has its own barcode.
Precisely. And SphereX can read those barcodes, even billions of light years away.
That's amazing. And it can tell us how much of that molecule is there and how it's spread out.
Exactly. So we'll have a 3D map of those life-sustaining ingredients.
This is incredible. We're talking about mapping the potential for life in the Milky Way, but let's be realistic. SphereX isn't going to find actual aliens, is it?
No, not directly.
Okay.
It's not designed to detect life itself, but rather,
Okay, go on.
think of it as a scout, identifying the regions where life might be possible.
So narrowing down the search.
Right. Like when you're looking for a new place to live, you don't just randomly take a spot on the map.
Yeah.
You look for areas with good schools, parks, safety. SphereX is doing that on a cosmic scale, finding the places with the right ingredients for life.
I love that it's like a cosmic real estate agent.
Yeah.
Showing us the best neighborhoods. So the big question, what are the chances that SphereX will find these life-supporting environments?
It's hard to say for sure, but scanning the whole sky like this definitely increases our odds.
Like casting a wide net?
Exactly.
Yeah.
Even if we don't find definitive proof, the data will be so valuable.
In what way?
It will help us understand how planetary systems form and evolve, which will help us in our search for life.
So no matter what SphereX finds, it's a win-win.
Definitely.
Before we wrap up, I want to leave our listeners with a thought. Imagine SphereX does find evidence of those molecules, those building blocks of life, in a region where planets are forming.
Okay.
What could that tell us about the possibility of other Earth-like worlds out there?
Well, it would be incredibly exciting. If those building blocks are common, it might mean that life isn't so rare after all.
So other Earths, other worlds teeming with life, it might not be science fiction.
That's the beauty of science. It pushes the boundaries of what we know.
And that's why I love doing these deep dives. It's all about sparking curiosity and reminding everyone that the universe is full of possibilities.
Absolutely. And with missions like SphereX, who knows what incredible discoveries await us.
Well said. And to our listeners, keep looking up, keep asking questions, and never stop exploring.
Maybe one of you listening will make the next big discovery.
That changes everything. Thanks for joining us on this deep dive into SphereX. Until next time.